Today we're going to talk about real zeros of polynomial functions. And we're going to find some of those zeros by using long division of polynomials. So you need to know how to do this. Okay, so here we're going to divide 6x cubed minus 19x squared plus 16x minus 4 by x minus 2. We're going to do this just like you did long division in grade school. So we're going to write down the problem here. Divide that by x minus 2. Okay, so here's what we're going to do. I'm going to say, okay, what do I need to multiply x by to get 6x cubed? And that, of course, is 6x squared. So I'm going to put that right above the 6x cubed. I'm going to take 6x squared times x is 6x cubed. I'm going to take 6x squared times negative 2. That's going to be negative 12x squared. I'm going to line it up with the x squareds here. And then I'm going to subtract this. Okay, this should go away. This becomes negative 7x squared. I'm going to drop down the rest of this. Okay, and then I ask myself, what do I got to multiply x by to get negative 7x squared? And that would be negative 7x. Negative 7x times x squared would be negative 7x squared. Negative 7x times negative 2 would be 14x. And then I'm going to subtract that. Okay, this goes away. I get 2x minus 4. Then I ask myself, what do I multiply x by to get 2x? And that would be 2. 2 times x is 2x. 2 times negative 2 is negative 4. Again, I subtract that, and I get 0. So this divided in evenly. Okay, so here's my answer right here. Piece of cake, just like long division. Okay, the division algorithm, this is one of those things you're going to have to think about, that if you read it in a book, it doesn't necessarily make sense. If f of x and d of x are polynomials such that d of x is not equal to 0, and the degree of d of x is less than or equal to the degree of f of x, then there exists unique polynomials q of x and r of x such that f of x equals d of x times q of x plus r of x. All right, so yeah, what does that mean? Well, basically that means if I take d of x times q of x, and then I add r of x, I'm going to get f of x. Okay, so I can divide f of x by a denominator, and I get a quotient, and I have a remainder. Okay, it can also be written like this. All right, it'll make more sense when you actually see it. So here we have 8x cubed minus 1, and we're going to divide that by 2x minus 1. Okay, so then I ask myself, what do I got to multiply 2x by to get 8x cubed? That would be 4x squared. 4x squared times 2x would be 8x cubed. 4x times negative 1 would be negative 4x squared. And then I'm going to go ahead and subtract that. And I'm going to get 4x squared. And then I got this minus 1 over here. Where this minus sign goes with that 1. So then I ask myself, what do I multiply 2x by to get 4x squared? And that would be 2x. 2x times 2x is 4x squared. 2x times negative 1 would be negative 2x. Subtract that. So now I get 2x minus 1. And 2x will go in there. Well, that would be 1 time. So that would be 2x minus 1. And I subtract again. And I get 0. So divided it evenly. Here's my solution. So if you go back and look, this would be f of x, and this would be the divisor x, so that'd be d of x, and this would be the quotient, so this would be r of x, or not r of x, q of x, and then the remainder would be 0. But if there was a remainder, if there was something left down here, this is what that last page was saying. It's all color coordinated. Okay. All right. Divide -2 plus 3x minus 5x squared plus 4x cubed plus 2x to the fourth by x squared plus 2x minus 3 using long division. All right. Let me make a suggestion here. Rewrite this function in order from largest power to smallest. That will make your life easier. Make sure this one is the same way. Okay, what I'd like you to do right here is pause the video and then go and try to do this by yourself, and then jump back on here and you can see what we got together. Okay, so pause the video now. Okay, so hopefully you did this. I need to multiply x squared by 2x squared to get 2x to the fourth. So this is going to be 2x to the fourth. 2x squared times 2x would be 4x cubed. And this 2x squared times -3 would be -6x squared. And then I'm going to subtract all of that. This goes away and this one goes away. I'm left with x squared plus 3x minus 2. And, oh, look at that. That's the same. Oh, wait, nope, not quite the same. So I'm going to multiply x squared by 1 to get x squared plus 1. So this is going to be x squared. This is going to be 2x. And this is going to be minus 3. And, of course, I subtract all of that. And I'm going to get left over here x plus 1. Now, this is a power lower than this. I can't divide it anymore. This is my remainder. So what I'm going to do is I'm going to go plus x plus 1 over this right here, x squared plus 2x minus 3. So if I go back to that equation, here's my f of x. Here's my d of x, here's my q of x, and there's my r of x. Hopefully that's what you got. All right, synthetic division. You can use synthetic division. It's a little quicker and easier. You got a lot less writing to do. But you can only use it when you've got an x minus k or an x plus k. If there's anything else here, if there's an x squared or something like that, you can't do it. Okay, and the pattern works like this. You strip out the coefficients a, b, c, and d. You write those down. You take your k, you put it over here. Notice it's minus k, so it's positive k over here. If this was plus k, it'd be negative k. And then you drop the a down, and then you go k times a would be ka. All right, and then you're going to go ahead and add these up. Then you're going to multiply it by k again, and you're going to get something else over here, and so on and so forth, until hopefully, if you come up with a 0 right here, it means it divided it evenly. And if it doesn't, then you have a remainder. So it'll be easier to see if we actually do one like this one. So use synthetic division. So I need to strip out the coefficients. Now you got to be careful. The coefficient here is 1. Now, there is no x cubed here, so I need to put in a 0. You need to have every degree polynomial that's inside here represented. Okay, so if there's missing one, you got to put in a 0. So then the x squared would be a -10. The x is a -2, and then you got 4. And then we're going to take a -3 and put it out here. We're going to drop down our 1. Now you go negative 3 times 1 is negative 3. Add it up, you get negative 3. Negative 3 times negative 3 is 9. Add it up, you get negative 1. Negative 3 times negative 1 is 3. Add it up, you get 1. Negative 3 times 1 is negative 3. You add it up, you get 1. Now, what does this represent down here? Well, this is the answer. So, if this was an x to the fourth, that means this one's going to be an x to the third. So this is x to the third minus 3x squared minus x plus 1 over x plus 3. There's your remainder. This will always be 1 power less than the previous one. The remainder theorem and the factor theorem. So the remainder theorem says if a polynomial f of x is divided by x minus k, then the remainder is r equals f of k. So let's say you just want to know, is this thing divided evenly or is it a remainder? All you got to do is plug this into here, so you'd find f of negative 2. So this would be 3 times negative 2 cubed plus 8 times negative 2 squared plus 5 times negative 2 minus 7. Okay, this is negative 8, negative 24. This would be 4 plus times 8 is 32, minus 10, minus 7. So this would be 8, negative 2, negative 9. So this would have a remainder of negative 9. If it comes out to be 0, then it divides in evenly. Okay? The factor theorem. A polynomial f of x has a factor x minus k if and only if f of k is 0. So that goes with this one. So if this had come out to be 0 right here, then x plus 2 would have been a factor of that equation. Okay? But it didn't. It had a remainder, so that didn't work. So show that x minus 2 and x plus 3 are factors of this. Then find the remaining factors of f of x. A couple ways you could do this. Since you have to find the remaining factors, which is what you're going to have to do most of the time anyway, or find the zeros, I would just divide those in there. So I would do this with, since these are x minus k situations, I would do this with synthetic division. So it'd be 2, 7, negative 4, negative 27, negative 18. It's a terrible 8. And we're going to put in a 2 right here. We're going to drop our 2 down. And let's see, this would be 2 times 2 is 4. That'd be 11, 22, that'd be 18, that'd be 36, that'd be 9, and that would be 18, and that would be 0. So that shows that that is definitely a factor. Okay, now this has to be a factor as well. So what I'm going to do, instead of starting all over, I'm just going to do this again. Oops, I meant that to be a different color. There we go. All right. Now I'm going to use negative 3. I'm going to drop down my 2 again. And then I'm going to go ahead and do negative 3. So this would be negative 6. That would be 5. That would be negative 15. That would be 3. This would be negative 9, and that would be 0. So that tells me that that is also a factor. Now I have to find the rest of the factors. So this was at 2x to the fourth. This is 2x to the third. This is 2x squared. I'm going to go ahead and rewrite this as 2x squared plus 5x plus 3. Okay? Now, hopefully I can factor this thing. So my factors here are 2x and x. My factors are 3 and 1. Now, I don't know if it's 3 and 1 or 3 and 1 here. But I need to make 5. So if I put the 3 here, I get a 6. And if I put the, okay, I can do this. this would be plus 6 minus 1. But the problem is, when I gotta always check this. When I take the last, if I'm going to FOIL this, everything works for this. But the last one, negative 1 times 3 would be negative 3 here. So that's not going to work. So I'm going to need to try this the other way. 3 and 1. Okay, so then it would be 3 plus 2. So both of these are plus. Okay, there we go. And now positive times a positive is a positive. So this is factored. So I already got, there's my last two factors. I've already got two other factors. I've got x plus 3 and x minus 2. And so I've factored this thing as far as it will go. Okay. Using the remainder theorem in the synthetic division. So in summary, the remainder r obtained within the synthetic division of a polynomial f of x by x minus k provides the following information. The remainder r gives the value of f at x equals k, that is r equals f of k. If r equals 0, then x minus k is a factor of f of x. If r equals 0, then k0 is an x-intercept of the graph. So all this stuff means the exact same thing. Okay, we kind of talked about that the other day. I wouldn't spend a whole lot of time worrying about this page. Okay, the rational zero test. So let's say you get this big, ugly, long polynomial right here, and it's got integer coefficients. Okay, so all the coefficients, all the a's here are nice integers, you know, -1, -2, -3, 0, 1, 2, 3. Okay. Then every rational zero has the form of p divided by q, where p and q have no common factors other than 1. P is a factor of the constant term a sub naught, a sub 0, and q is a factor of the leading coefficient. Okay, what does all that mean? Let's look at it in practice here. And this is probably not the best one to do this with because it's all ones. But here's what you do. You take this, okay, this number, the constant number right here, okay, and its factors are plus or minus 1. And you divide that by the coefficient, the factors of the coefficient here, which are also plus or minus 1. And so the possible rational zeros now are plus 1 or minus 1. Okay? That means those are the only ones you got to check. So remember, what are rational numbers? Rational numbers are numbers that can be written as a fraction. Okay, so whole numbers can be written as fraction, like 3 can be written as 3 over 1. Okay, 2/3 is a rational number because it can be written as a fraction. Okay, so what that means is, if I was going to do synthetic division here, I'd have a 1, a 0, a 1, and a 1, because remember I got to leave the 0 for the x squared. I only need to check these two numbers, okay, because nothing else is going to work. Now here's something to keep in mind. These are all positives. That means I got to cancel them out. If I want a 0 at the end, I got to have a negative. So I don't even need to check the positive one, because if I put a positive 1, look what's going to happen. It's going to be 1 times 1 is 1. 1 times 1 is 1. Then I get a 2. 1 times 2 is 2. That's a 3. It's just going to get bigger and bigger and bigger, right? So there's no way to make it 0 if there's not a negative somewhere in this problem. So I don't even need to check the positive. I already know it's not going to work. So I'll check -1. -1 times 1 is -1, which I add up to get -1. -1 times -1 is positive 1, which is 2. And then I get -2, which is -1. So here's the deal. Neither one of these rational solutions worked. Okay? So this does not have any rational zeros. So there you go. Find the rational zeros. No rational zeros exist. There might be other zeros, but they're not rational numbers. Okay. Let's try this one. Find the rational numbers. So, again, I take the factors of this are plus or minus 1 and 3, because 1 times 3 is 3. I divide that by plus or minus the factors of this are 1 and 2. All right, so my possible rational solutions are 1 divided by 1. I mean, it's always plus or minus, right? So it's 1 divided by 1 would be 1, 3 divided by 1 would be 3, 1 divided by 2 would be 1/2, 3 divided by 2 would be 3/2. Those are all the ones that I got to check. So I'm going to do my synthetic division. 2, 3, -8, 3. Drop my 2. All right, let's try, don't try big extreme numbers, and don't try your fractions usually first. Let's just try 1 and see how that goes. 1 times 2 is 2. That makes 5. That's 5. That's -3. That's -3. That's 0. Okay, that worked. So I got a factor, or I've managed to get this down. This is now 2x squared plus 5x minus 3. Now, when I usually get this down to an x squared situation, I tend to factor it. I don't use synthetic division anymore. Okay, you could. So we could try. We could try another factor here. In fact, you could do the same one maybe again, which is not a bad idea to try sometimes. So 2 times 1 is 2. That'd be 7 up, 7 up. That's going to have a remainder. All right, so let's try -1 instead. So that'd be -2. That would be 3. And -3 would be -6. That didn't work either. Okay, so it might be none of these work. A faster way to do it, when you get down to a quadratic equation, is to just factor the thing. So this would be, I would rewrite this as 2x squared plus 5x minus 3. And you could use the quadratic formula too if you wanted to. Let's see, if I go 3 and 1. Okay, and then I go plus 6 and minus 1, and then that makes -3. So here we go. So if I want to know what the zeros are, let's see, this would be 0. So 2x minus 1 would be 0, which would mean 2x would be 1, which would mean x would be 1/2. Hey, guess what? Should have tried 1/2. Okay, and then this one, x is -3. That's pretty easy to see. So that's also one of my choices up here. So I had 3 rational solutions, and they were all 3. I knew they had, if there were rational solutions, they had to be from those numbers right there. So my zeros, I'll just list those out. My zeros were 1, -3, and 1/2. Okay. Find all the real zeros of this. All right, since, let's see, they're not all even, so I can't factor any of the numbers out, but I can factor an x out. So let's do that. We'll take f of x, we'll factor out an x. That leaves me with a 10x cubed minus 15x squared minus 16x plus 12. Okay, my possible rational solutions. I take my factors of 12, which would be plus or minus 1, 2, 3, 4, 6, and 12. And I would divide that by the possible rationals of, or factors of 10, which would be plus or minus 1, 2, 5, and 10. All right, so let's do some synthetic division here on this. 10, negative 15, negative 16, 12. Let's just try a 1 and see what happens. So this would be 10, that'd be negative 5, that'd be negative 5, that'd be negative 21, and I can tell it's not going to work. Negative 21 is going to leave me a remainder of 9. So I need something bigger than a 1. So let's try 2. You don't want to go too big because this will get wild fast. Okay, so we'll try 2. So this would be 20, which would be 5. This would be 10, that'd be negative 6, that'd be negative 12, and that'd be 0. Okay, we got one. Okay, so now this is x squared, 10x squared, 5x minus 6. I don't want to go through synthetic division and guess this. I'm thinking factoring is not going to be much fun either, is it? I'm probably going to quadratic formula this one. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, so these two negatives cancel out. And I get negative 5 plus or minus the square root. All right, this is 240 right here. 265. Wow, that's hideous. Over 20. Okay. Those are not going to be rational numbers. This is not a nice square root right here. So what did it ask me to do? It said find all the real zeros. Well, I found the real zeros. So one of my zeros is going to be 2. One of my zeros is going to be 0 because that was the first one that I found right here when I factored out the x. So if you just have an x, that means that it's going to be 0. Okay, so there's 2. There's my rational ones. And then I've got x is going to be negative 5 plus the square root of 265 divided by 20. And the other one is going to be negative 5 minus the square root of 265 divided by 20. So there's 4 zeros, 2 rationals, 2 reals, and it's degree 4. That's all the zeros that it can have. So I'm done. So the best way to find the real zeros, when it says to find the real zeros, is to find the rational ones first and get them out. And get it down to a quadratic formula, and then you can use the quadratic formula to find the rational ones, or the real ones. Okay. So it looks like we got an assignment here. The assignment is on the next 3 pages here. So there's page 1, page 2, and page 3. Okay, and here's your problems right here. So do those to the best of your ability, and I will see you next time.